This session is going to be on trigonometry for Math 20-1. Now, we do come into Math 20-1 trigonometry with some background knowledge. I don't want to spend a ton of time on the background knowledge, but I think it's important we have a little bit of a review here. So we are under the understanding that all of us know what SOHCAHTOA is. And so I will just write this down, and that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And the other thing that comes as kind of prerequisite knowledge is that we need to know how to use Pythagoras. That will come up as well. So a squared plus b squared equals c squared if you're finding the hypotenuse. And then we can reorganize it to be a subtraction if we're finding a missing side. Now, don't worry too much if those things are still a little hazy. I will, when we get into a question, I'll flush out doing sine, cosine, tangent, Pythagoras, etc. Okay, but this is our prereq come in knowledge from whichever course you decided to come into. You might have come from 10 common, you might be coming from 20-2. It just depends on what your trajectory is. So that's what we should know already. Now, what is new, or what we're going to do in 20-1 is we're going to start, and I rarely do this, so just so you know, I don't often say memorize this, but I'm going to tell you there are two special triangles that come up over and over and over that we're going to memorize. So if you're taking some notes, which I see that many of you are, I want you to memorize what a 30, 60, 90 triangle looks like. And it's not too hard, but it does take you, a little bit of time. So 30 degrees, 60 degrees, 90 degrees. So across from the 30 degrees is the side length of 1. Across from the 60 degrees is a side length of √3. And across from the hypotenuse is a side length of 2. Obviously, you don't need to put those arrows every time that you're writing a 30, 60, 90. So it would be a 30, 60, 90 triangle is a 1 √3, 2 triangle. So as the angles get bigger, the side lengths get bigger. Like this is 1.732 is what √3 is. So that might help you to remember as well, which one goes where. It takes a little bit of time to memorize that, but you need to have that kind of in your back pocket. The second one that you need to memorize that is really quite helpful is a 45, 45, 90 triangle. So draw yourself another right triangle. Each of these are the same, so it's an isosceles triangle. Across from the 45s are 1s, and across from the hypotenuse, or from the 90, the hypotenuse is √2. So here for 45, 45, 90, it's 1, 1 √2. This one's a little easier to memorize because there's really only 2 numbers to memorize. Okay, so that's some more base knowledge that we need to kind of have. So depending on where you are, you might have run across these, you might not yet have run across these. So that's one piece of information. Now, up until this point, we've only been asked to deal with angles less than 90 degrees. We haven't looked at what happens if we work with angles that are greater than 90 degrees. So let's take our calculators out. If you've got your calculator handy, it's helpful. If you didn't bring it, no worries, don't panic or anything. But if you have it, this would be kind of cool. First off, please check that your mode is here under degrees, just to make sure if the radian is darkened, move your cursor down and over till it's on top of the degree and then hit enter. Okay, so I'm going to show you something that gives rise to some conversation as to why this next part of the trig math kind of arises. So in your calculator, so there's our memorization part. In your calculator, please just go sine of 30 degrees and find out what you get for an answer. Just leave it on your calculator. If someone wants to type me in the chat what you get for an answer, great, but that's okay. We've got quite a few people here, so we don't have to if you don't want to. So sine of 30. Then I want you to do this. Something kind of cool is going to happen. Math is cool. Find the sine of 150. Do it the same thing. Go sine 150 equals, and find out what that gives you. Something very cool. Yes, as was noted by a student, we get 0.5 here and we get 0.5 here. Something's going on here. There's a pattern that's going to emerge. Again, some of you that might be ahead might know what the pattern is. But this is kind of cool. Let's do a cosine question. So let's find the cosine of 30 degrees. Write it down. And then find the cosine of 330 degrees and write it down. Now, I know something that possibly some of you don't know yet, right? That's the beauty of learning our math. And someone could type up there for me, what do you observe when you do cos of 30 and cos of 330? What happens there? So the answer here, the answer here. Aha, I got someone help me out here. Yes, same thing again, right? We get different numbers. These are 0.866, but this is also 0.866. There's something afoot with cosine. And then obviously you may suspect that I'm going to do a tangent question. So let's do, I don't know, let's do tan of 60. And then let's do tan of 240. See what happens when you do tangent of those two numbers. I get 1.732 and double check that I didn't make any silly error. No, I get 1.732. Okay. Have I convinced you guys there's a pattern we need to learn here? Right? There's something that I know that you don't know that's going to make our life much easier as we go through these questions. It's something called the cast rule. Ooh, I don't know where that came from. Sorry about that. 1 second. Do you guys see a ruler come up on the board? Always a new thing here. I don't know how to get rid of my ruler. Oh, I clicked it. Sorry about that. That's what I did. Okay, so let's learn about the cast rule. We are going to now put angles on a grid, like a graphing grid, where we start with 0 degrees here, and we go counterclockwise. So up here, this is 90 degrees. Back over here is 180 degrees. Down here is 270 degrees. And if we go all the way back to the beginning, we would go a full rotation back to 360 degrees. Okay. And then we can draw angles within there. If we go and do, say, the sine of 30 and the sine of 150, let me show you why the answer turns out to be 0.5 in both places, and then flush out the cast rule from there. So if we're going to draw a triangle with 30 degrees, it doesn't matter how perfect your drawing is, just get it in the right quadrant. So 30 degrees looks approximately like that. Now, probably the most important thing that I'll tell you this morning. When you are finishing your triangle, you must finish it vertically like this. Never do it horizontally like this to the y-axis. Don't do this. I will erase this, but don't ever do it horizontally. Everything that we do in reference to graphing angles is done in reference to the x-axis. So always finish your triangle up vertically. Now, remember, you've got your notes in front of you there. It's kind of off the screen in terms of the special triangles, but we just were asked to memorize the special triangles. I don't suspect you've got them memorized quite yet, But across from 30, you might remember I had put a 1, so we can put the number 1. The hypotenuse is always a 2, and the adjacent side is √3. So again, you just memorize it and then you just place it in there. Now, remember I was saying that we're going to go back to the definition of sine, cosine, and tangent. So using the definition, not our calculator, the definition is that it's opposite over hypotenuse. So the sine of 30 is 1/2, which is indeed 0.5. So that backs up the fact that if I was asking you, graph it please on this grid and show me the work, this is how you would show it, okay, rather than just default into your calculator. Now let's explore the sine of 150, because this is kind of the first time we've been asked to mess around with bigger angles than 90. So we go in a counterclockwise direction. Remember how I was just showing you that? You're going around this way. We just need to get in the right quadrant. So just has to be in quadrant 2 between 90 and 180. I don't care how perfect it is. It's just over here somewhere, okay? So 150, I'll use a different color of pen here. It goes from here around to here, like that. Okay, so we've got it drawn. So we need to get a triangle over there. Now there's something called a reference angle. The angle is the little angle here, I'll darken in. The angle between your terminal arm, your hypotenuse, and the x-axis. Now they're usually pretty easy to find. You can tell that if we went all the way around to the negative x-axis, we would have gone 180 degrees, but we've only gone 150. So our reference angle here is 30. So again, I can break that out. The way we find that reference angle is 180, take away 150. Gets us the 30 degrees. Now, we know lots about the 30-degree triangle as long as we make it a triangle. So again, like I mentioned, and I'll say this over and over, always complete your triangle vertically and then fill in your sides. Don't worry about positives, negatives here. We're going to talk about this cast rule. It's going to solve everything about graphing positive, negatives. So across from 30 is a 1, hypotenuse is 2. The missing side is √3. I know that if we're doing graphing, it should be minus √3, but we're not going to worry about that right now. We're just looking at that triangle. So now let's look at over here, what would we do for sine of 150? Well, the definition of sine never changes, is opposite over hypotenuse. So the opposite side, I'll just use the orange again, is 1. And the hypotenuse is 2. That backs up why we all of a sudden came up with the same answer. Now, what is this cast rule all about? The cast rule is a short little kind of a word that I don't want to say cheat, but it helps us decide whether the final answer for our trig ratio is going to be positive or the final answer for our trig ratio is going to be negative. And here's where the cast rule letters come from. In this first quadrant, all of the trig ratios are positive. So the A comes from there. In this quadrant, sine is positive. The S comes from there. And we'll do some questions. In this quadrant, the tangent is positive. That's where the T comes from. And in this quadrant, the cosine. So kind of odd. Cast starts on the 4th and then goes up and around. But do you see, I'll use some highlighting here. You see when we did the cosine question, it was 330, right? 330 is somewhere in this quadrant here, between 270 and 330. It came out to be positive. The same thing as cos 30. Tangent is over in the other quadrant here. The 240 is somewhere over here. It came out to be positive. So the cast rule helps us quickly get to the answer and know whether it's positive or negative. Okay, so there's kind of our baseline. We did a little bit of messing around on our calculator to explore the idea that, oh, different angles have the same final answer for a trig ratio. Let's jump into a question now and go kind of from start to finish. Not using our calculator, we've got our special triangles that we hopefully got kind of in our mind. Let's look at what some of these questions would look like. Okay, so it'll say something like this. Draw and find the following answer. And say we're going to be asked to find the tangent of 200. Nope, not 200. Sorry. Let me just add 120 degrees, not 200. 120 degrees. Okay, so we want to draw a triangle and find the following answer for tan of 120 degrees. Here's what this looks like. Draw yourself just a little grid. Again, remember I had mentioned, we don't care how perfect our triangles or our diagrams are, as long as we're in the correct quadrant. So we need to be in that quadrant 2 again. Somewhere over here is 120 degrees. We need to find this reference angle. Someone type me up what the reference angle would be. What's that number going to be in there? Perfect. Thank you very much. So that is 60 degrees. Excellent. Again, we go from 180 back to 120 to find it. All right. Now, I'll give you a moment. There's your triangle. Remember, again, I connected it vertically. Label your 3 sides. Don't worry about positive negatives. That's really not of great concern. Cross from 60, put the number that you think it is. Cross from the hypotenuse, put the number you think it is, and then do your adjacent. I'll just give you a second to get ahead of me. Okay, so across from 60 is root 3. The hypotenuse is always 2. The missing side is 1. We're going to take care of positives, negatives with the use of the cast rule, so we don't really have to put it on our diagram. If you do decide you want to put -1 on your diagram, that's totally fine. Okay, there's your lovely diagram. You would get a tick mark for that. Now, tan of 120. Again, tangent is opposite over adjacent. So I said I was going to kind of review these with you as you went. So the opposite side is root 3, directly across from our reference angle. We use our reference angle for this. And the adjacent is 1. Now we look at the cast rule to decide if the answer is positive or negative. Okay, so I don't normally write that down, but I know you're taking some notes and it's the first time that you're going through these questions. So we look at the cast rule. So I write the cast rule down, C-A-S-T. We are located in the S quadrant. That means sine is positive. That means tangent is negative. So we go up here and we say our final answer for tan of 120 is negative. There's our final answer. You can drop the 1 on the bottom and just put minus root 3 if you want. You can leave the 1 on the bottom, doesn't matter. So that's how you complete a question when you're asked to draw a triangle, draw a picture and find the following answer. Let me throw one out at you. And then I'll sit quietly for a minute and let you have a chance to try to draw it and get the answer and send me the answer. And then we'll talk about it. Okay, so let's do a second one. Just got to clear my board off here a little bit more. Oh, sorry. My board is being a bit of a pain. Okay, so we got another spot. Okay, so let's do this guy. Example 2. Draw a diagram and find, you could say the exact value. That's some terminology that I should probably throw in there for cosine of 225 degrees. Okay, so I'm going to give you guys a shot at it. I'm just going to be quiet for a few minutes and let you guys have a kick at it. So let's have a look at how cos 225 rolls out here. So we draw a diagram. Again, we just get it in the right quadrant. So if we need a little reminder, this is 0, 90, 180, 270, and then all the way around to 360. So it's in this bottom quadrant over here somewhere. So our 225 goes like that. So to find that missing angle, we go 225, take away 180. It should be, always an angle that you know something about. If it's not, then I've designed the question wrong in 20-1. So this will be 45 degrees. Again, remember to do it vertically. Do not go across to the y-axis. Always go up to the x-axis. And then the side lengths are 1, 1, root 2. Again, I don't worry about putting the negatives in the diagram because I use the CAST rule as my catch-all to make sure that the answer is positive or negative. So cosine of 225 is, adjacent over hypotenuse. I don't need to see that every time. I'm just trying to remind you as students. So adjacent is 1, hypotenuse is root 2. And then the CAST rule, C-A-S-T, we're in the T quadrant, which means tangent would be positive. Therefore, our answer is negative. So there's our final answer. Now, some places you'll see them rationalize the denominator. I'm not going to worry about that at this stage in our course. We haven't done radicals yet in our course. And so I'm going to take 1 over root 2 perfectly. Okay, I had a question here. Why is it 1 and 1? Well, there's a special triangle that we had right at the beginning of the class. I'll just put it over here and remind you. I'll do it in green. The special triangle was 45, 45. That's not very dark. I apologize about that. And the side lengths were 1, 1, root 2. So I just memorized that root 45 triangle, flip it upside down. And then across from the 45 is the 1, and the hypotenuse is root 2. So the missing other side is 1. So we just have to memorize those special triangles. Anything else before we move on? There's one other type of question I want to cover. Same idea, kind of presented to you a little bit differently. Okay, don't see any others. So I'm just going to go down here and clean off my board a little bit again. Okay, so there's another type of question that we can be asked. I think this is example 3, where it might not rest on special triangles. It's again going to be asked a little bit differently. So it's going to say something like this: solve. And it'll say something like cosine of theta. And theta is just a Greek letter we use, just like ABC. It's just from the Greek alphabet. The Greeks were quite responsible for a lot of the trigonometry that we study. So we are going to have some decimals here. So let's say our cosine is 0.146. And then it's going to say this: 0 is less than or equal to theta is less than or equal to 360. So this looks quite significantly different than what I just was doing, but you're going to see that some of the same ideas are put into place. Now, what does this mean? Let's kind of draw out what this means. This means that we have to look all the way around a grid. So when we're looking, we draw our grid here. We are allowed to find answers in any of the quadrants around in a 360-degree manner. Now, CAST rule tells us that cosine is positive here and here. So when we get our answers, we're going to have an answer that fits within quadrant 1 between 0 and 90, and an answer that fits in quadrant 4 between 270 and 360, because those are the ones that are going to be positive. So let's look at how this works. Okay, this is the first time we've used our calculator to do inverse cosine. So in your calculator, what you would do is go cosine to the -1 of 0.146. So if you're not remembering how to use your calculator because you're just kind of immersing, it's second function cosine. You put your 0.146 in, and then you hit enter. So those are your calculator buttons if you're just kind of getting back in the swing of cosine. And we'll round off to the nearest degree. So we get 82 degrees. So that's not too hard. That part of it's not kind of anything new from say grade 10. So we can draw that. Again, diagrams don't need to be perfect. It's somewhere here, 82 degrees. Now, because we'd already checked cast rule, we know there's got to be an answer for this down in the bottom quadrant. So we can draw this here. We know it's down there somewhere. And our reference angle is the 82. Whatever angle is in the top is our reference angle in the bottom. Then our angle, our entire angle that we're trying to find, is from here all the way around. So to find that answer, we go 360, take away 82 degrees. Because if we've gone around an entire circle, we would get back to 360. We subtract, that will be our second answer. So in your calculator, go 360, take away 82, 278. Okay, so I'll put this over here with the work shown. 278. So our final answers then are 82 degrees and 278. Now, the reason I really like trigonometry is most of the time you can check your work, which is really, really nice to know you're handing something in you know is correct. So if you want to, you can take your calculator and go cosine 82 and get point. Now it's not quite 0.146, it's 0.139 because we rounded, remember? And then do the cosine of 278 and make sure you get that same number. And so we're sure that we've got that correct answer. And one more question, and then we're going to wrap it up, and then I'll stick around if there's any questions from anyone about anything else. All right, let's get rid of a little bit more stuff on my board. This one, it's going to look harder, but you're going to see that once we get started, it's not really any different. It is like one of them on the assignment. I want to say it's like 5B. I'd have to go and look at the assignment, but anyway, so example 4, solve, and it's going to say something like this. 4 sine theta equals, let's see. That'll work. 2.455. 0 is less than or equal to theta is less than or equal to 360 degrees. So again, we're looking for answers in an entire rotation. My whiteboard's being a little bit ornery. Okay, so let's get our diagram like that. Before I do anything in the diagram, we need to deal with this guy right here, that extra 4. So let's deal with it. And what I mean by deal with it is we need to get rid of it. It's multiplied. So we're going to divide both sides by 4 before we do anything. So get your calculator out and go 2.455 divided by 4. Get 0.61375. Okay, now I would pause for a minute once I've got that and go, okay, sine is positive. Cast rule tells me that I need to get a final answer in quadrant 1 and quadrant 2 in A and S. Okay, let me give you a shot at trying to find the 2 answers then. So do the same process as we had for cosine. Second function sine, find your angle, then go and try to find the second angle, round them to the nearest degree, and then send me what you get. All right, so let's look at how to solve this one. We've got this trig ratio, sine theta is 0.61375. So again, we're going to use our second function button on our sine, on our calculator for sine. So theta is going to be sine to the -1 of 0.61375. So that just means second function sine and then 0.61375. And I get 37.86. So I rounded off, I just said to round to the nearest angle. So I get 38 degrees. So we go on to our picture and we go, okay, our first angle looks like this. Again, just generally getting in the right location. Remember, this is 0, this is 90, this is 180, this is 270, background 360. We need to be in the next quadrant. So our other angle is like this, something, doesn't matter, just get in the right spot. Our reference angle is the same. Whatever angle you find at the beginning is your reference angle in your second picture. And then we are going to find our angle from here to here. So in this quadrant, we go 180, because that would be around halfway. You subtract the 38 degrees, and you get your second angle, 142. So our second angle here, I'll put the work down here, 180, take away 38 degrees is 142 degrees. And so moving us down a little bit, our final answer then is 38 degrees or 142 degrees. Okay. There we are. So that's going to wrap up the portion on working on special triangles and the cast rule.